Hello everyone, welcome to my channel. So today's our LeetCode daily challenges, step-by-step directions from a binary tree node to another. Okay, so basically we are given a binary tree, all right, and we are given the starting value and the destination value, right? And what we have to do, we have to return the string which shows us the shortest path of moving 3 to 6. Okay, so in this particular example, what we if we want to move from 3 to 6, what we will do, we will move upwards, then upwards, right, then in the right direction and downwards, right, and then in the left direction, right, downwards. Okay, so what would be our answer? UURL. Okay, so to solve this problem, we will break down this problem into two parts. First, we will find the LCA, that is the least common ancestor, right? So suppose we are given 6 and 4 of this tree, right? And we have to find the LCA. So what would be our LCA? It would be 2, because just the parent ancestor of these two values, right? And suppose if 2 and 4 are given, then what would be our answer? Our answer would be 2, right? And we won't even move to 4, right? Our LCA would be 2. Hope you have got it, and hope you know the code of LCA. All right, and why we are finding the LCA? So as to minimize the problem. So suppose we are given the starting value 6 and the and destination value 4, then what would be our answer? We have to move up U, and then we have to move right. So R, UR would be our answer. All right. So so basically, by finding the LCA, what we will do, we will update our root with this LCA value. So our new tree becomes this much only, right? We have get rid of this particular extra tree, right? And now I have to solve only this particular tree, right? And now the coming to the problem, like how we will come to know that we are moving upwards from 6 to 2. So basically, what we will do for this, we will further divide this particular problem into two parts. First, from the root, because see, root is the intermediate point. LCA will definitely be the intermediate point of these two starting and destination values. Okay, so what we will do, we can do one thing, because we know like starting and the destination definitely have to move through this. We will find first the start string from 2 to 6, and then we will find the destination string from 2 to 4. Okay, so what would be our starting string? And we will follow the same function. Like when we are moving left, then we will update our string with the L, otherwise we will be updating our string with the R. Okay, so what will be our start string? From 2 we are moving to 6. So we will the starting string will be L, and that's all, right? And destination string, what would be the destination string? From 2 to 4 we are moving right. So only R, right? So what we will do then, we our start string hold L, and our destination string holds R. So we will simply replace all the values of the start string with U, because see, till this root we will be definitely moving upwards, right? Like suppose was our LCA, then from the start value to the root, we will definitely be moving upwards. Okay, so we can replace left and R with U, and the destination string will be the same. And after it, we will concatenate the start string and the destination string and return it, right? That would be our answer. So in this case, it will be U and R, okay, for this particular string. And for this particular big string, like 3 and 6 are the values, what will be the LCA? Just the parent node of these two strings. So what is the parent node of both the strings? That is 5. Okay. So in this case, what will be our start string? Right, right. And what we ever will be our destination string? Right and left. And we will basically update this start string with all the values with U. So UURL. That would be our answer. So right. Hope you have got the logic. Okay. So coming to the code. This is our code. First, we will find the least common ancestor and update our root with it. So, what is the code for the least common ancestor? So, this basically there are only three conditions in this LCA code, least common ancestor code. Suppose this is the problem, right? So, and the start well is 6 and destination value is 4. Then what would be our LCA? 2, right? And suppose the only problem is we have to find two. We are given the starting value 2 and destination value 6, right? Only this tree I'm talking about. What would be the LC of this is this? It will be 2 only, right? So what we will so I will get to the point why I'm going to say. Let's take one more example. Suppose we are given this tree and the start value is 1 and the destination value is 2. What would be our LCA? 5. Now, how we will find it? First, we will move to the left, right? As soon as we find start well, right, or the root well, or it becomes null, we will simply return the root, right? So, what is its root? Its root is 5, so we will return 5. 2, when we will route to 2, 2 is the destination value, so we will return 2, right? So both 1 and 2 exist, so we will return p. If both of these exist, then we will return the root. If only 1 exists, then we will return 1 only. If only 2 exists, we will return 2. So, right, this is the code for it. If root is null, root value is start val or root value is destination val, we will return R. Otherwise, I will move towards the left, right? And in R, we will move towards the right, right? If both exist, then we will, if both the value exist, then we will return root. If only the left exists, right? Because there is nothing, then we will return root the L value. And if only right, then we will return the right. And in this way, we will get the LCA. Okay. So now we will make two strings, a start string and destination string, right? First, I will find the value from the root value to the, so like suppose LC is 5, right, in this example. So, but I will send a start value, it is 3, and the start string, which is currently empty. Okay. Now I will come to the recur function. So if root is equal to null, our root is 5, it is equal to null, then return 0. So it is not true. If root value is equal to value, so 5 is equal to 3, no. So we will not return 1. Okay. So we will move forward and we will, what we will push? We will push L here. Now we will move to here. Okay. Now again we will reach here. So from this, right? Because we have called recursion and the string holds L. Root is null, no. Root value, that is 1 is equal to 3, no. So we will, what we will do? We will move forward. We will not return 1. And again we will push L. So L is into our string and we have reached to 3. Now, is root is null? No. Is root value is equal to value? Yes, 3 is equal to 3. So we will basically return 1. So from here we will return 1 here, right? And as soon like we will reach here, and if root is 1 is equal to, if a is equal to, like if a, from here we have received 1, right? That is true. So if true, return 1. So we will basically, here is null, but we will not move here because we have find the answer here. So we just need to follow this part. So right. So I will return here 1 from here, right? So again we have reached here. Okay. And again what we will do from 1 here, we will return 1 from here because bool, if because we have get 1 from here, so 1 is also here. So from 1 we will return 1, and this basically returns LL, our string hell LL, and it we will come to here, and our start value will be keeping values left and left, that is LL, right? And again we will do, for now we have to find this particular path. Okay, so what I will do, I will send the destination value and the destination string. Destination string is currently empty. Okay, again coming here, if root is equal to null, return 0, but our root is not null, so we will move forward, right? If root value is equal to value, 5 is equal to 6, no. Then what we will do, we will move forward, we will push L, right? We will push L. Okay, and right, so will push L, and where we will move? We will move towards this, right? We are moving towards 1, and again we will reach here. Root is not equal to null, and 1 is not equal to 6. We will again push L, right? And now we have root to 3. Now again we will move towards, like, root is not equal to null and root value, that is 6, is not equal to 3. Again we will move left. So left is null, right? Null. So we will return 0. We will receive 0 here from the left. So here we will receive 0. Okay. Now here we will receive 0 if a is equal to, if a, that is a is equal to 0, so return 1. So but it is 0, so it will not return 1 and pop back. So basically we have push L here, so we will pop back L. So now our string contains only L. Okay, hope you have got it. Now we will move to here. I will push right, that is L, and R will be our string, and I will be moving towards the right. But right is null, so again I will receive 0. Okay. So when I receive 0, what we will do? We will pop back. Our right value will also be popped back. So we will come to here. Okay. So here only. Now our string contains basically nothing because we have popped out left and right values. Okay. Now we will moving to the left. We move to 2. We check whether our root is null, right? Whether our root is null, we are here. So our root is not null. So and our root value is not equal to, that is 2 is not equal to 6. We will move forward. Now we will again come here and push L. So basically this L is here. All right. R and then L. We have got the answer here. So but we will return 1. So 1 will be here. When we receive 1, we simply return it. We do not move towards the right. So basically, our we will again return 1 from here. So what the string holds L and R. So our start string holds LL and our destination strings has R and L. And as we know, we have to update all our start string values with U. I will do it, right? I will move through the uh, start string and update all the values to U, and I will simply return start plus destination, that is U, U, L, and R. Okay. Hope you have got this problem. If I run it, yep, it is running successfully, and yep, it is accepted. So hope you have got the solution. See you in the next video. Till then, bye.